All right, so if you're watching this video, it means you're still struggling a little bit with mole to mole conversions, and that's okay. So I'm going to go a little bit slower, and we're going to just lay everything out again and tell you the steps. So first thing you're going to do is you read the problem and you identify all the information that you need in the problem. So it says how many moles of fluorine, okay, so that's what we want to get to, that's our ending point, are necessary to react completely with 11.7 moles of NH3. That's our starting point. So we're also going to look at the reaction, which is up here. And I look and I see, oh, it's balanced. Okay, great. I'm ready to start. So then I'm going to use the number and unit given in the problem and start with that. So I have 11.7 moles of NH3. And just like we've always been doing, we put it over 1. Then we take the unit and the substance and we bring it down. So moles of NH3 comes down. What goes on top is the number that we want to get to, is the unit we want to get to, which is the moles of fluorine. So that goes on top. Now the biggest issue is, well, how do I know what numbers to put next to moles of fluorine and moles of NH3? That's why we have a balanced chemical equation. So I look up at the equation. I have a 5 next to fluorine. So that's going to go next to fluorine in my ratio. Then I look at the equation. I have a 2 next to NH3. That's going to come next to NH3 in the ratio. So now I have the numbers where I need them. I'm going to cancel my units. And now I do the math. So I multiply 11.7 times 5, divide by 2, and I get 29.25 moles of fluorine. Okay, next question. How many moles of hydrofluoric acid can be produced from 0.75 moles of ammonia with excess fluorine? Well, first, we are starting with 0.75 moles of NH3 or ammonia. That's where we're starting. We want to get to moles of hydrofluoric acid. Now, kids struggle and they say, well, what does this excess fluorine mean? Well, for the purposes of the problem, we can scratch it out. We can ignore it. But what it means is there's plenty of fluorine to react with the NH3, and we don't have to worry about it. So now I'm ready to start setting up my train tracks. So I start with the number and the unit and the substance. So I have 0.75 moles of NH3, put it over 1, draw my line, and remember the first thing you do is bring moles of NH3 down. That's where I'm starting. Now where am I going? I'm going to moles of HF. Okay, I have the units. Now, how do I know what to put next to those substances? Look to the balanced equation. What's next to HF? What's a 6? So a 6 is going to go right here. What's next to NH3? A 2. So a 2 is going to go right there. Cancel my units. It's 0.75 times 6. Then divide by 2. And I'm going to get 2.25 moles of HF. Okay, number 3. If 3.8 moles of N2F4 are produced, how many moles of HF are also made? So we are starting with moles of N2F4. We are ending with moles of HF. So I'm only concerned with this side of the equation. I don't care about my reactants. I only care about how much is produced. So I start with number and unit given in the problem. I have 3.8 moles of N2F4. Put it over 1 and then draw my line. First thing we do is bring the unit and substance down. So moles of N2F4 come down. I have that taken care of. Now I want to get to moles of HF. Sometimes kids say, well, what about the fluorine and the ammonia? I don't care. I don't care about this side because that's not what the problem's asking. Now I need to figure out what numbers to put next to HF and to put next to N2F4. I look in the reaction. So what I have is I have a 6 next to the HF. So that's going to go next to the HF in my ratio. I have a 1 next to my N2F4. So that's going to go next to my N2F4 in my ratio. Cancel my units. And it's going to be 3.8 times 6. And I get 22.8 moles of HF. All right, question 4. Calculate the number of moles of ammonia needed to produce 7.2 moles of N2F4. So I'm producing N2F4. I want to figure out how much NH3 I need. Don't care about the fluorine, don't care about the HF. So now what I do is I start with number, 7.20, unit, moles, substance, N2F4, put it over 1. First thing you do, bring the unit down, moles, N2F4, that's where I'm starting. I want to get to moles of ammonia because that's what's given in the problem. Now I have to figure out what numbers to put next to it. Well, there's a 2 next to NH3, so that goes here. There's a 1 next to N2F4, so that goes there. Cancel my units, multiply across the top. I get 14.4 moles of NH3. Okay, question number 5. Again, we read the question, we figure out what are we starting with, where do we want to get to, and identify what we're going to put in our train tracks. So we have how many moles of ammonia are needed to react with 7.3 moles of fluorine. All right, I'm starting with 7.3 moles of fluorine. I want to get to moles of ammonia. So I start with my number, unit, and substance. So I have 7.3 moles of fluorine. Put it over 1. Unit and substance comes down. I've taken care of this. Now I want to get to moles of NH3. So moles of NH3 go to the top. Now to figure out what numbers I put next to each of those units, I come to the equation. There's a 2 next to NH3, so a 2 goes here. There's a 5 next to F2, so the 5 goes here. I cancel my units, multiply across the top, divide by the bottom, and I should get 2.92 moles of NH3.